And greetings, space weather types. Welcome to another edition of the Daily Space Weather Show. Another solar uptick going on as we speak. Massive solar filaments continue to dominate the Earth-facing portion of the solar disk. And some oddities going on with some instruments. We'll cover it and lots more today at the Smash News Network, least busted name in news. Thanks for tuning in and stargazing with us. That's the last 24 hours from the Solar Dynamics Observatory. 171 angstroms, the house favorite ionized iron wavelength. Here's a little closer look at the equatorial region. And again, we do have multiple new sunspot groups forming, which we will cover. Here we've added 131 angstroms. Highest likelihood of solar flares remains in the northwestern limb, which would be the upper right portion of the Earth-facing solar disk. Also, like I said, massive filaments. Some of them have names. Some of them are yet to be named. Almost none of them have ejected. And check it out, some of that activity around the northern polar region has become a crown prominence. So as we get closer and closer over the next probably around a year till we see solar maximum, you can expect to see more of those crown prominences. That is when there is a filament hanging off the edge around the polar region. It is the same feature as a filament. And here's the equatorial view, which indeed shows lots of solar plasma filaments. These are the prime suspect to become coronal mass ejections, which we've actually seen a bit of a shortage of over the past few days. Statistically speaking, that's not likely to continue. There's the southern polar region. Filaments, filaments, filaments continue to be indeed a relevant story when it comes to the features of the closest star. So here's a quick look at the SDO continuum. So we've got a little bit of evolution in this sunspot. A new group formed ahead of this sunspot, which has been growing in the past 24 hours. A new sunspot group formed right up here, right in the center of the Earth-facing solar disk. So at least 2 new sunspot groups likely to get names today. This is also yesterday plus today. Like the SDO continuum, the colorized magnetogram showing August 15th and August 16th to date. And let's take a look at volcanoes. So first of all, we've got Fuego here, the purple skies around Fuego there, a common feature of sulfur dioxide filled skies there. They turned the skies purple. Great imagery there of Fuego, and also some imagery here of Revenador. Let's check the rest of the list and see what else has been erupting. So Subanose Jima producing a 6,000-foot ash plume, now back on the list. Semeru exploding, flight level 150. It's a 15,000-foot ash plume over East Java. Shishaldin doing some explosive activity there, a paroxysm, characterized by tall and dense ash columns. About a 16,000-foot ash plume there, flight level 160 over the Aleutians from Shishaldin. Fuego exploding, over 15,000-foot ash plume there at Fuego. Lava bombs. Beware of lava bombs. Also Sangay in Ecuador exploding. Flight level 200. It's a 20,000-foot ash plume. 15,000-foot ash plume from Revenador. Sabancaya exploding. Flight level 230. 23,000-foot ash plume. And the world's largest volcanic ash plume is over Peru. Ubinas producing a 24,000-footer. Please do not pole vault the caldera. By the way, there's been a shakeup in our merch shop. If you check them out by order of best selling, you'll find that at the top of the list, the second place, the second bestseller, which was the bestseller for a couple of years around 2020, has replaced Universum Liberate. Today's featured product is Do Not Pole Vault the Caldera. This public service message is brought to you at massive personal risk and expense by Smash staff and I, so why not give her a raise by picking up some merch? Many people, including us, have fallen on hard times, very hard times, nearly unsurvivably hard times. However, things will look up. So if you're, to quote Winston Churchill, if you're going through hell, keep going. You'll emerge at the other side. There's a light at the end of the tunnel, and you'll emerge stronger. By the way, save 30% on the merch items. Site-wide, links below the video to the merch as well as on our homepage at smashomash.com. And next we'll cover earthquakes. So there's the 90-day bar graph. We are getting into a bit of a 7+ magnitude earthquake drought here. The past 24 hours have not featured many large events, but quite a few earthquakes in general. We'll cite quakes of a 5 or greater magnitude. Starting out with this 5.1 at Japan. It occurred at 1707 Universal Time last night. That 5.1 at 36.2 kilometers estimated depth. There was also a 5.2 at Turkmenistan. That was at 1:37 Universal Time this morning. And that was at 44.8 kilometers estimated depth. Then, later this morning, at 4:09, a 5.2 occurred in the Santa Cruz Islands region there. That is east of Australia, north of New Zealand. It was at a depth of 224.4 kilometers. And those are the only 5+ magnitude quakes. There was a quake here north of the Cascadia Fault Zone there, a 4.4 off of Canada there, near Prince Rupert. The fuck? Okay. Yeah, let's return to space. So here's the past 24 hours from the SDO in 304 angstroms. That's ionized helium. And it is one of the classic wavelengths. We do stream this all day long on the Twitch channel. You can see that at smashomash.com/SmashTeam. Shout out to our Smash Team members. Thanks for continuing to make these videos more likely to continue to exist. Let's break down some important statistics, like the 10.7 centimeter radio flux, which is now at 158 solar flux units. Another small uptick from yesterday. Here is the one-year chart to put that in context. It's the black line here. The red line below it is the sunspot number, and you can expect a further increase in the sunspot number and the radio flux in the coming days. That graph from Solon.info. Space Weather Enthusiast dashboard forecasting a little bit of geomagnetic unrest starting first thing tomorrow morning. That's from a coronal hole high-speed stream, and we can expect the density wave to show up any time from that coronal hole high-speed stream. Now we're going to talk coronal mass ejections toward the end of the space weather video, in between space weather and meteorology. It looks like NASA has made a weird forecast here. Here's NASA's Enlil spiral, and they're showing a CME here going off to the east of Earth. I think they have that completely wrong. I believe that was actually off to the west, but hey, sometimes it happens. Not exactly sure there. Maybe they'll update that one, but we'll show you why that does not appear to be correct. It appears to be off by like 150 degrees. Anyway, let's take a look at Earth's magnetic moment from space. These are the past 4 hours, Earth's geospace magnetosphere movie. And it is very geomagnetically calm here at the moment. We have a very slow solar wind, which we are expecting to be replaced within about 12 hours by a fast solar wind, what we call a coronal hole high-speed stream. So that's the past 4 hours of magnetohydrodynamic pressure. Here are the past 4 hours of Earth's magnetic moment from the ground. This is magnetic flux density. And again, it is quite geomagnetically calm. We should get a great signal when we do indeed see that coronal hole high-speed stream show up. We can expect to see any time now an increase in the solar wind density, followed by a decrease in the solar wind density, and an increase in the solar wind speed. So there are the past 4 hours of Earth's magnetic moment from the ground. Quite calm and unremarkable for the past 4 hours. KP index now at 2.33. The planetary K index, if you're not familiar with it, if you're new to the channel, welcome. Congratulations on realizing it exists. The KP index, or planetary K index as it's called, is an average of global geomagnetism. So current conditions are, again, like I said, very slow. Only 306 kilometers per second for the solar wind speed. Solar wind density here about 6.3 protons per cubic centimeter. That is currently measured by the ACE, depicted by the green line there, down here at the bottom where it says KPAP. That is the ACE spacecraft. And we are seeing some shifts in the magnetic field happening here as we produce the video. So a little bit of an increase and a shifting of the vertical component there. So the BZ, which is the red line up top, has now shifted into negative territory, which is more conducive to geomagnetic activity on Earth. Next, the GOES magnetometers, and we saw a big spike there measured by the GOES 18 just before it maneuvered. So those arc jet moments, those are the spacecraft turning on their thrusters. Those thrusters create plasma, which can affect the magnetometer readings. So perhaps that big spike was caused by its positioning. The GOES 16 and GOES 18 are geosynchronous near equatorial comets. They're geosynchronous near equatorial spacecraft, and the N's and M's up top there are depicting noon and midnight local time for the satellite to give you insight as to their location with respect to the sun's location. Noon and midnight local time for the satellites. Next, our top view ecliptic plane field plot, and there is a sector boundary crossing. You can expect that to arrive by the time tomorrow's daily space weather video comes out. So if we bring up the last image here, here is a sector boundary crossing right here as Earth is about to snap into a North Pole current sheet and out of the existing South Pole current sheet. Let's take a look at the line of sight field plot next. That's what's going on with the sun's B field, the polar fields, and this grayscale depicts the gong magnetogram. Polar fields in red and green for south and north respectively. And here's coronal holes. So the current coronal hole high-speed stream is likely to be caused by these South Pole-oriented coronal holes, kind of stretching from the northeast to the southwest. These are all south. Over here we've got a North Pole, and down here we've got a major North Pole coronal hole here rotating in. So like I've said, we've been having a shortage of coronal holes. Don't expect that to continue. And those North Pole coronal holes down there in the southeastern limb are likely to become much more well-defined in the coming days. So here's the breakdown from this is the SDO 211 angstroms 24-hour video. These are North Pole, these are South Pole, and coming down here are some major North Pole coronal holes there. So those look like they'll be geo-effective as well, as that coronal hole shortage is coming to an abrupt end here. Next, sunspots. So that's the sunspot scenario. And again, we are seeing a couple of new groups. Expect 2 new groups to get names. This one up here. That one will probably be 3408. And this one down here should be 3409. Here's a view of sunspots from yesterday plus today on the SDO intensity gram. So there's one new group and there's another new group. These are, I think every one of these sunspots here, except for one or two, are at least beta gamma class sunspot groups. So they're all magnetically complex. That does raise the potential of solar flare activity. And here's 1600 plus 1700 angstroms from the SDO AIA instrument. That is ionized helium. That's the 1600 angstroms. And the 1700 angstroms is similar to the continuum. It is a series of different features there. 1700 angstroms is not a particular chemical spectra. 1600 is. That's ionized carbon. Next, energetic particles and solar flares. The GOES proton flux here remains flatline for the past 3 days. No spikes, no major flares. So there's the flare profile. And the background flux has indeed moved up to around a C-class level here. The average X-ray output here is definitely above a C-class. Coming up a little bit here as forecast. There's a 7-day graph. And there's the 3-day graph. Again, the most likely place for large flares would be the northwestern limb. So here is, that's 94 angstroms, another 24-hour video. And you may see some activity down there in the southwestern limb. There was a CME that came out of that area, which was why we find it so weird that NASA modeled it missing Earth to the east. Anyway, hopefully they're watching our videos. Maybe they'll realize that it's way off. Here's another 24-hour video. 131 angstroms from Solar Dynamics Observatory. And just to reiterate, I think this area is by far the most likely place to see a large flare in the coming 24 hours. So fingers crossed for that. And don't forget to look up. When you do, you might find it useful to have a star chart. Our star chart is from skyandtelescope.org if you want to make your own. That's what's going on over Lehigh Valley. Jupiter high on the ecliptic at the moment. Saturn has already set. And Venus, in the next couple days, will become a morning star. It'll be very bright there, rising ahead of the sun. Next, your solar system forecast. There's where things are today. And happy new moon, by the way. Here's where things will be in a week. Mercury speeding up to catch up. And Venus speeding away. And let's talk about the astronomy picture of the day. It's totally sweet. It's a galactic merger. Mergers and acquisitions. Those are happening in the Milky Way galaxy. Did you know the Andromeda is destined to become one galaxy with the Milky Way? Now these two that are merging, they're only about 20,000 light years apart, those two galactic cores you see there. This trail of material created in the gravitational merger, that trail is about 200,000 light years in length. So to give you some perspective with respect to the Milky Way galaxy, that trail there is about twice the diameter of the Milky Way galaxy. So that's the astronomy picture of the day from apod.nasa.gov. That is NGC 7285 on the right and NGC 7284 on the left. The single gravitational object is known as ARP-93. A cosmic embrace. apod.nasa.gov. By the way, if you want to do citizen science, check out Zooniverse.org. Yeah, Zooniverse.org. And we've classified a bunch of galaxies and done some other stuff. One of the things that you can do here is check out the different projects. There are different projects in all sorts of different sciences. One of them is space. And maybe we'll show you some examples tomorrow of the different features in the space science. We've mostly done galactic classification, as AI cannot solve all of science's problems, folks. We need human beings to analyze some of the data. That's people just like you. So citizen science, the largest citizen science project in the world, is Zooniverse.org, and that is what we'd call bandwagon advertising. And let's take a look at coronal mass ejections here. Here are yesterday's, and one did occur just after we produced yesterday's video. So you can see that coming out of the southwestern limb there. We do not anticipate that to be earthly directed. It's somewhat behind the southwestern solar limb. And that would be the CME that NASA seems to have forecast going the opposite direction. NASA has that going off to the east. It's clearly off to the west. Not sure what's up with that, but those are yesterday's images from George Mason University. Here are today's images, an additional 42 frames. Pretty quiet so far. Today, August 16th. Now we have paused this here just to show you that those are, well, there is some material coming out of probably the far side of the sun there. So around 1500. I just don't think there's an earthly directed component there. And I think that is certainly mostly off to the west, not to the east. Let us know in the comments what you think. And let's talk about Stereo A. So Stereo A has been looking very funky in the past days. I don't have a theory as to what it is, but it looks like there are some calibration problems happening with Stereo A, as it has now evolved into an even weirder looking situation. Let's take a look at that briefly here. So here's Stereo A over on the left, and you're going to see two different things happen. You're going to see the view shift. The obscurement disk here shifts off to the east. So that's pretty strange. And then it gets even weirder. It shifts again, and it looks like it's showing the solar disk here. So not sure what's going on with Stereo A there, but it doesn't look good. So it's already not very helpful because it's practically right in line with the Earth, so it doesn't help with calculating the trajectory of a coronal mass ejection, like whether it's earthly directed or not. But now it's looking even worse. Stereo A. I think it needs calibration. So anyway, we'll show Soho-Lasco C2 and C3 instead here. And then we'll show our custom coronagraph images. Again, we do not anticipate those to be earthly directed coronal mass ejections. And here are our custom Soho-Lasco C2 plus the SDO 193 angstroms wavelength. So you'll see down here in the southwestern limb, you see a CME happening there. We don't see any limb darkening, so all indications are that that is on the far side of the sun there, not on the Earth side. And here's a little closer view. Those are, once again, 24-hour videos. And here we'll subtract the Soho-Lasco C2 and zoom in. There's a full disk view, which is the SDO 193 angstroms. Next, filaments from El Teide, Spain's ground-based solar observatory. And again, there are a huge number of huge filaments. The densest and most massive filament is currently up here in the northeast. Check that one out. That is a gargantuan filament indeed. That one could get a name after living people, and if you want to name it, follow the hashtag #NameThatFilament over on the platform formerly known as Twitter. Hashtag #NameThatFilament. Also a pretty big one down here. The Mike Smith filament remaining quite intact. We also like to show the grayscale image because it shows prominences. We've got quite a few prominences, especially around the western limb. We'll zoom in a little bit closer on those. And then we'll show one more 24-hour video from SDO. The full disk view here from 193 and 304 angstroms wavelengths. Great at showing filaments. The extended corona, active regions, coronal holes. And here are the past couple of hours from the GOES 16 SUVI. That's 304 angstroms. So again, we have seen a bit of a shortage in the past few days of coronal mass ejections. Those filaments do not typically stay anchored forever. They have a tendency to either eject, reorient themselves and re-anchor someplace else, or collapse. Sometimes they do a combination of those three things. And statistically speaking, that's not likely to continue. So expect an uptick in coronal mass ejections. Expect the coronal holes in the southeastern limb, the North Pole-oriented ones, to become more well-defined in the coming days as less plasma blocks the view of those. And keep an eye on the northwestern limb, the upper right, for solar flares. And that brings us to bonus features. There are some minor satellite charging hazards here over the eastern Pacific. They are of the surface charging variety. That's when electrons build up on the outsides of spacecraft. Don't expect any major communications breakdowns from those. Minor surface charging hazards over the East Pacific. GOES electron flux here dipping, and you can expect to see this dip way down into the range where it's likely erroneous. So this will be on the floor on tomorrow's daily space weather video from the incoming coronal hole high-speed stream. At the moment, it's at lower levels than yesterday, but just in a sort of low to moderate range. So there is that's the one-year graph of the relativistic electrons as measured by the GOES 16 and GOES 18's radiographic measurements from their geosynchronous orbits. They measure that at about 300 kilometers of altitude. There you can see NOAA's forecast is for a large dip in the electron flux as well. So no argument there. That's what we would expect to see. And again, they're measured at the F layer of the ionosphere, which is at about 300 kilometers of altitude. Here is the vibrational frequency of that layer. The diffuse gas at the bridge between Earth and space is vibrating. It is a series of charged particles, and they do react to things like incoming sunlight. So that's what's going on as far as the raw vibrational frequency, and we're seeing mostly high-frequency anomalies here, I think, at the moment. But don't worry, we'll show the anomalygram as well. Once the coronal hole high-speed stream strikes for, say, 12 hours in earnest, you can expect to see a lot more low-frequency anomalies showing up here. This data courtesy of the Australian Government Bureau of Meteorology. So lots of blue on the map there. Those are the high-frequency anomalies we're talking about. This depicts anomaly in megahertz from the 30-day median. Here's the latest image. That's 12:15 universal time for the ionogram and 12:15 universal time for the anomalygram. We also show total electron content daily on the channel. It'll show you the most likely places for GPS errors. So if your GPS is likely to have errors, try using Wi-Fi location accuracy, That could help if there are Wi-Fi hotspots, as those have known physical IP addresses, and they can help you navigate. Typically, when we do see space weather activity like coronal mass ejections and coronal hole high-speed streams, we do see more anomalies occurring in the total electron content forecast. Normally, we also show North America's anomaly. Unfortunately, that is still not loading here, and the rest of these are looking erroneous, so let's move on and close out the space weather section with the latest intensitygram and the latest colorized magnetogram. So we've got beta-gamma class sunspot groups almost entirely. That's beta-gamma class. That one there is beta-gamma class. That one there is barely beta-gamma delta class. Beta-gamma class. That one's beta-gamma class. This new one up here is beta-gamma class. That just means that there are two opposing magnetic fields, both north and south polarity. And it's time to move on to the meteorology segment. But before we do, let's talk about the channel. Again, I'm aware that people are having, shall we say, difficult financial times indeed. So is the channel, as it is constantly in danger of going out of existence at any moment. So if you appreciate the content and you're in the market for some Hemp Lucid products, why not purchase them through our shop? You can find a link below this video to our Hemp Lucid paid affiliate. So check that out. It is the second newest paid affiliate that we have, in hopes of keeping this channel existent. So pick up some mushroom gummies, perhaps. I am an advocate of the stress mushroom gummies as well as the focus mushroom gummies. Even CBDs for your pets available there from our Hemp Lucid shop. Now, again, hard financial times mean you should save cash. Almost everybody uses black pepper, right? Salt and pepper. They're sort of the standard table seasonings of the Western world, because of some king in England or something used to like black pepper or something. So buy your black pepper in bulk. It's extremely expensive. So why not save a bunch of cash by getting a 30-ounce bulk black pepper and stop paying like 20 bucks a pound at the grocery store? Get it from our Amazon shop instead at Amazon.com/shop/Smashomash, also linked below this video, and conveniently on the homepage at Smashomash.com. So here comes our meteorology segment. We're going to start out by showing the world's currents and sea surface temperature anomaly. So let's start talking about the Gulf Stream first, which, by the way, isn't shutting down. Europe certainly did not have a year without a summer. So a lot of people idiotically forecasted that we would have a year without a summer in Europe, and it was quite the opposite. Last I checked, it was kind of hot, as water from the Gulf Stream makes it up here to Ireland and Iceland, preventing an ice age across the northern hemisphere. A lot of warm water up there. And Ireland and Iceland are not frozen, just in case you're wondering. So that's sea surface temperature anomaly. That's the color gradation. And the animation there is ocean currents. So let's zoom out to the full planet view here. There is the Arctic. Quite anomalously warm water here north of Eastern Europe and north of Asia. Anomalously cool water there off the coast of the Bering Sea there, western Alaska. Overall, the Atlantic here, North Atlantic quite anomalously warm, South Atlantic a mix. So fairly average there for the South Atlantic. Here's the Indian Ocean next. Mostly anomalously warm. Southern Ocean. Mostly anomalously cold. And there is the Pacific, the world's largest body of water, largest surface heat sink. The North Pacific, very anomalously hot. The Equatorial Pacific, anomalously hot. And sections in between, anomalously cool. Our viewers are anomalously cool. So let's show global weather patterns. First, the surface winds of the east side of the planet. Large anticyclone here off the coast of Australia. That counterclockwise rotation indicates a high pressure zone. So it's windy and clear, probably, over that portion of the southern Indian Ocean. Here are the jet streams of this side of the planet. Here are the jet streams of the central world. Surface winds of Europe, Africa, and Central Asia shown here. Surface winds of the west shown here. I realized about 20 years ago it was too easy to forecast the weather. That's part of the reason why we do space weather. I also realized I needed a deep dive into heliophysics because of the implications on cosmology. So we throw in the meteorology segment as a value-added service, a bonus feature upon a bonus feature. These are the jet streams of the west. Next, our humidity map. That's just showing, I believe it's relative humidity. Must just be humidity, as relative humidity is not going to be 28% over Montana. That's just the raw humidity from windy.com. Next, we'll look at clouds and fog over the Americas. As we zoom in closer and closer to the lower 48, the shortwave radiation map is great. It shows clouds and fog at nighttime. It's 3.9 micrometers infrared radiation. And here's your weather.gov map. So Pacific Northwest continues to see excessive heat, also southern Texas. And there are some systems trying to form off the coast of Hawaii. They're being tamped down by Saharan dust, as we showed on yesterday's meteorology segment. Windy conditions here over Lake Michigan and Lake Superior. Next, your forecast. That is the GFS 72-hour temperature anomaly forecast in degrees Celsius. And it looks like there is a respite coming to the Pacific Northwest here. You're going to see some anomalously cool temperatures rolling in about 2 days. Again, that's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Here's the GFS 72-hour pressure and precipitation forecast. And guess what? There's snow showing up in the forecast for Colorado and Utah. Check it out. It looks like that's not snow. That's just a high pressure zone. I thought I saw blue on the map there. That's just the high pressure zone. Last but not least, this is the conductor of the orchestra that is Earth's weather, the jet stream forecast. It's based on the same model, the 72-hour GFS model. It depicts 250 millibar winds. And in a couple days, the jet stream is going to be almost entirely north of the U.S., which will largely allow convective forces to take over. And you might see some weird weather here coming in a couple of days. Next, we've got the lightning mapper. That's the past about 10 hours. Lightning around the Gulf Coast and around the East Coast for the most part. Also a little bit in Utah, Arizona, Mexico, and Southern California. Do we have any terrestrial strikes in the U.S.? Doesn't look like it. Next time you hear thunder, check it out, lightningmaps.org. it's highly recommended. Quite a bit of lightning here in the Gulf and in the Western Atlantic. Also Central Europe seeing some thunderstorm activity, and also Western Europe. By the way, if you enjoy the content, do yourself a favor and press subscribe. It is the most comprehensive daily space weather content in the known universe. Also the most detailed imagery of the sun. And it's the only channel, as far as I'm aware, that's explaining the solar sunspot cycles to its Gold Smash Team members. Pretty sure nobody else is doing that. When that paper passes peer review, it'll just be the most important science paper in hundreds of years. No big deal. So become a Gold Smash Team member. After you press like and subscribe, press the share button if you're an influencer. Drop us a line. You want us to appear on your channel and talk about space, talk about weather, or talk about literally anything? If you think I'm in your political tribe, probably not. I've got extremely nuanced stances on practically everything. And if you want to support the channel via subscription services and get additional content, become a member of the Smash Team. Smashomash.com/Smash Team officially launched on October of 2021. There's a bronze level, which will cost you $0 a month, a silver level, which is $2.99 a month, and a gold level, which is $9.99 a month. Smashomash.com/Smash Team for additional content. And if you want to read my crap theory about what mechanism underlies the solar sunspot cycles, that's for gold members only. Gold Smash Team members get all kinds of perks. You can even get an @smashomash.com email address. Most first names still not taken. Hit us up at smashomash.com if you want to find our social media accounts, links to the YouTube channel, links to the Redbubble shop, the Hemp Lucid shop, and the Amazon shop that we discussed earlier. Smashomash.com launched in February of 2019 in response to the ridiculous, putrid, disgusting censorship on the internet. We saw the writing on the wall. We launched our own website. And welcome to the Neo-Renaissance. There is a revolution coming in the realm of cosmology. We're going to close this thing out with U.S. Doppler radar. Heavy precipitation here around southern Alaska. However, we'll focus on the lower 48. Here's clouds and fog, 3.9 micrometer infrared radiation once again. And there is the water vapor map. You can see the jet stream dipping down there toward Missouri. That cold Canadian air. And here's your recap. Vertical motion in the air column from ground-based systems known as Doppler radar. Space-based infrared radiation in the 3.9 micrometer infrared wavelength. That is the shortwave radiation map. It shows clouds and fog even when it's dark over the western portion of the country, which it is. And last but not least, the water vapor map. And check it out. This is a really weak low right here. You see this counterclockwise rotation indicating that it is a low pressure system. However, it's all encased in Saharan dust. So there's a little bit of convection trying to happen in these areas, but it's not working out very well because the dust is not helping. So that's the kind of a situation that could form a hurricane if there wasn't so much Saharan dust, but there is. There is, Blanche, there is. And so it's probably going to be pretty uneventful. Anyway, thanks for tuning into the Smash News Network, least busted name in news. We'll see you soon with additional content. Who knows what kind? Who knows what will happen next, but we'll cover it regardless. While I'm gone, may that solar wind be at your back. I've been your host, Dan, a.k.a. Smashomash, signing off.